Good morning, Professor. This is the team Trifacto, and our project is ASU Event Management Database System. And the team members are Monica, Shushmita, and myself, Pavitra. So this is the one-page summary of our project. Our project focuses on building a database management system for the university's event happenings, which is happening throughout the year across different campuses. Keeping track of such events in papers or notebooks will only make things hard. So through this project, we have centralized all the event related happenings such as event sponsor, event volunteers, and so on under one database management system where we can control and manage them easily.
So once we decided on our project topic, we wanted to be clear with our purpose, which is the database must hold solid information about the events and participants. Further, what is the valuable and meaningful questions that can be answered in this database was jotted down. We first listed down the various entities and attributes, then we went on to decide the primary and foreign keys of the database. We then went on to develop the relationship between them by using the logical and conceptual model. We also normalized our tables following the various normal forms. Once we had our model completed, we went on to build few meaningful queries in SQL Server that would answer the purpose of the database.
For NoSQL, we used the Couchbase database, and then we did create 3 buckets to include all the events, persons, and event registration details in the key value format. So the bucket names are ASU events, persons, and event registrations. So all these 3 buckets have the compressed version of all the 10 tables that we have in SQL. And as we know, NoSQL is a document-oriented distributed database. This query and analytic mode were very helpful for us. So the query editor was helpful for creation and insertion of data, whereas the analytics editor was helpful for the analysis of the event management details that we had. And then the window functions, which are used for computing and aggregating the functions. So the first value and the cumulative distributions were really helpful to analyze the lot of concepts related to documents, as this has given us a chance to experience agility and the manageability of NoSQL's performance. Our main agenda here is to present the project overview, the conceptual, logical, and the physical database designs in our SQL server, the normalization of our tables, and also the NoSQL implementation using Couchbase, and then the future enhancements. The project overview. In our project, we are creating a database for the ASU events that happens in all the 4 campuses of ASU, as this will be centralized and easy to manage. This project is implemented in SQL using Microsoft SQL Server Management Studio and in NoSQL using Couchbase. The important questions that our database system will answer are like the number of registrations for an event and the seats remaining, or how to fetch a report to gather all the event details between 2 dates, and then how can we make a user to check if a payment is done or not, or the top 5 volunteers who have actively volunteered for various events, and also finding out the event campuses that host the maximum number of events, and to find out the available dates to block the further events. So this is the high-level description of the conceptual design showing cardinality and relationship between the entities. As you can see, the event and person entity is acting as a primary bridge between most of the entities. Next, we come to the logical design, which explains the structure of the entities as detailed as possible. Here, the category table and the department table, though they are related to the event table, which is a strong entity, has a primary key on its own. Next, we have normalization. We did perform normalization on our tables to reduce data redundancy and complexity of data. Our tables comply with 1NF, and we did make them comply with 2NF by removing the partial dependency of attributes on the primary key. We also made our tables comply with 3NF by removing the transitive dependency of the attributes on the non-primary key. Thus, we created and inserted data into our tables using DDL, TCL, DCL, and DML commands. So this is the physical database design. after creating tables in our server. So now we'll be explaining the queries in the SQL.
So once we created the various tables and implemented various DDL commands, we went on to implement the DCL commands, using which we created various server logins. This is mainly done for security purpose. You can see that we have created logins here like manager, sponsor, marketing manager on the server, which is also found in this part of the screen. Also, we created various users on the database event management. So this is done so that the various users can have access on, and we also granted few permissions on tables. Using this, they can perform any manipulation on tables if they have access like insert, update, delete, or they can just view the data using select permission. So next step, we inserted data into the DB and we put the insert block statements into the try catch blocks using TCL commands, so that even if any one command fails, a rollback of all the insert statements will happen. So this is how we have done our insert, and our final data is being displayed here in these tables. These are all the select commands. So we also created indexes on the primary table so that for speedy recovering of data from the query. So next we will move on to the important questions that will be answered by our database. Our first important question is the total number of registrations for an event and how many seats are still available. Since there are various events happening in ASU all around the year, and this database hosts all the important information, with the number of registrations available for an event minusing the registrations that have already been done, we can get to know our final result. Here we have joined two tables, event registration and ASU events with the count, and we have passed the parameter value as Spring Career Fair, and you can see that the result is here, that the event type is free and the total number of seats is 1000, number of registrations is 3, and the number of seats remaining is 997. So our second question is how we can fetch a report to gather all the event details between 2 dates. So with this DB, we can generate the event details with event manager and sponsor details. So we created a store procedure, and by passing the dates value as parameter, we can get a report for a specific period like either monthly, weekly or yearly. So here we have executed this query, and you can find the results here where it gives detailed results about the complete event. So next query is how can we check if a user has made payment for an event or not. So using this query, the admin or event manager can get to know the details of people who have registered for a cost event and made payment, and also people who have registered and yet to make a payment. So the string here, payment done and payment yet to be done, is being assigned to local variables, and a union condition is being formed here to fetch these details. So you can see the query results here where it denotes that for an event name, a particular person, the payment is done and the payment is yet to be done. So these details can be found from this query.
So moving on to the fourth question. So this query is to find the active volunteers. This list can be used to report such volunteers who are actively involved in extracurricular activities apart from their academics. So we've used aggregate function count and on the event and from the event volunteers table, and group by person name. So this is the query. Let's run it. This is the top 5 students, and this is the number of events they have registered for. Moving on to the fifth question. This query is used to find whether a person is registering for an event he or she is already registered into. So it raises an error if he tries to register twice. Else it will tell us if we are eligible to register. So this is a stored procedure. So yes, and then we're going to be passing the event ID and the person's ID. So this person has not registered before for this particular event ID, so he can register. And so moving on to the sixth question. So this query is used to know which campus is majorly used to hold events. This is used for analysis and statistical purpose to know whether to know where maximum participation lies. So let's run it. So according to this data set, we have ASU Tempe campus.
So now we are going to explain few examples of various stored procedures, CTE, functions, triggers, cursors, and views. So first we created a CTE to find out the number of registrations recorded for a particular category. So this CTE shows the event registration, which is total by grouping, the event category, and having count on the grouped category. So you can see the results here where the category and the number of registrations for the particular category is being displayed. So we created a view for our project, which can be provided to the event manager or sponsor of a particular event to keep track of event registration or seats available or seats that are remaining by giving access to this view. And since we are giving a particular access only to the view, they will not require to have the access to the entire database. So if we run after creating the view and run the query, this will be the results. So this is like after a particular date, whichever events are available. So since there is an option where the user can register and pay later, we created a cursor where the data is selected such that if a user exists in the registration table but not made a payment yet, and his details are not there in the payment table, mail can be generated using the cursor such that their details are being fetched row by row, and we are setting a message with their name and sending and configuring it and sending it to their email ID, which is available in the ASU contact details. So you can see once you have run this cursor, few of the messages here which will be sent to the Gmail is being provided here. And if you go and check the mail, this is the template of how the email will be received.
So moving on to the functions, we have the function with event price, and then this function is created to find the cost of an event when the event ID is given. This function takes an event ID, which is an integer as a parameter, and then returns the decimal data type value of the event cost. Local variables are declared in the function, and data is fetched from the tables using joins depending on the parameter value. So let's run the function. And we are trying to find the event cost of an event with event ID 5. It is 10. So if I change it to 4, it will give the cost of the event, which is 40. So, and moving on to stored procedures, this stored procedure name is SP venue block, and so this is when the user passes the location and date as a parameter. The script will let us know if we can block it for any further future events. The data is being checked in the table ASU events. We have used cursor here for query to go line by line to find out if the location is free to block, and it raises an error if it's not available. This procedure also demonstrates the working of a cursor with open, close, and deallocate statements on a cursor, and we have used fetch status function is used to check whether the fetch statement is successful. So let's create the stored procedure. Sorry. Let's create it. And let's run the stored procedure. Then we are trying to block the library for that particular date. It says event location is available to block, which means we can go ahead and block. So moving on to triggers, we have created a trigger tr_ASC event instead of insert. This is a trigger we have created here in that instead of instead of insert, we have restricted the user to insert values into the ASU events table for the events which are being scheduled on the same date and at the same venue. This way, no multiple events will collide at a particular venue on the same date. So for this, let's create the trigger. And we're trying to insert value. So we are blocking ASU Tempe Noble Library, and first time it will allow us. And here 2 rows are affected because of this inserted default table here. And then the second time we try to execute it, it'll tell us that the venue is already taken and that we have to block something else. Thank you.
Our project is also implemented in NoSQL database using the Couchbase server. Here, the data is stored in the key value format in the form of JSON docs. We created buckets to store the JSON documents. Query editor was used for running queries on the JSON documents for creation and insertion. The differences between N1QL and TSQL were like the N1QL can work with null and missing values unlike SQL. The execution time differences can be seen for large data as there will be quite a lot of change in the execution plans of the queries. One advantage here is that the 10 SQL tables is now compressed into 3 big tables in the form of JSON arrays. Next, we'll be showing the query execution for the Couchbase queries.
So as Sushmita mentioned, we have implemented our project in NoSQL as well. So for that, in Couchbase, we have reduced the number of buckets to 3 from 10 tables in the SQL. We have ASU events, person, and event registration buckets. And using the key value format for JSON documents, we have combined the primary key and the foreign key references into embedded array in our buckets. So as you can see, the ASU event, event registration, and person are 3 buckets we have. And in the documents, we can you can see that we have already inserted values into each of these buckets. Like this is the person bucket, and then we have the ASU events bucket, and then we have the event registration bucket. So this shows that this is how our key value JSON document looks like. And so moving on to indexes, we have created primary index for each of these buckets. You can see that here, primary index, ASU events, event registration, and person. And then finally, in analytics, we'll explain some queries now. So for that, this is the first query where this query is used to obtain results about various events from ASU event bucket. This is similar to the query we generated above on SQL server, where just by specifying the dates, the user can get to know details of the events that are going to happen between those dates. The only difference is that SQL server use a relational model, and we fetch the data by joining 2 or 3 tables. Here, all the data is just available together in one bucket itself, and it's fetched from one table or bucket. This is the output. Yes. Moving on to the next query, we have the list of events. We have the list of events and its corresponding number of volunteers. So in this, the count aggregate function is used, and by using the select query, we found out the number of volunteers each of the event has been allocated with. This is similar to the query which we did in SQL, where we were able to find the top volunteers using such query. So this is the number of volunteers which are for this particular event, and 3 volunteers for Junk Card, 2 volunteers for ME After Dark, and so on. So moving on to the next query, we have this query to display the event name, event location, and the last day to register for the event. So this query tells us the last day for registration for an event along with the event venue and the event name. We have used the window function first value here to give us, and we have partitioned by event name, and at the end we have ordered them by the event date. Let's exclude it. So we can see the latest event that is going to happen is Jankar, and the location Gamage, and then the last registration date for this event is January 20th, and for the next event is Research Symposium happening at Art Center, and so on.
So this query is to display the top 5 events with the maximum registrations. We ran a similar query using SQL, and to retrieve this result, we probably fetched the data by joining 3 tables. And since in Couchbase, it provides logical grouping using object within a cluster, We have used nested array concept to store multiple registrations under one event, and also the event details are stored in array inside the registration bucket. So if you see here, we have done a select by using event.event name, and the count is done on the person name. So this will be the number of registrations, and the group by is done using the event name and ordered by the number of registrations in descending order. And we've used the limit by 5. So using this, only the top 5 registrations can be derived. So I've already executed this. You can see the results on my screen, where we have Sun Hacks, MU After Dark, and a few other as the top 5. Also, you can find the JSON output over here. So our next query is to find the cumulative distribution of volunteers for each event. And for this, we've used the window function cumulative underscore distance. And the answer will always be between 0 and less than or equal to 1. So the higher the value of the volunteer distribution, their ranking will be higher to that. So we have partitioned using the event name and ordered using the event ID. So you can see the result here, and the volunteer distribution is seen. To get a better picture, we can also see in the table view, which is more clear. So our final query for Couchbase is to find the expected revenue of each individual event. And this is the total revenue expected from multiplying the number of seats available and the cost of each event. So we have displayed the results which are greater than 0, and we have displayed by using expected revenue in descending order. You can see the results here. We have 2 results, Junkar and Research Symposium, and the expected revenue respectively. We can also find the JSON output over here. And to sum up, overall, it was a great experience to have experimented our queries and implemented it in Couchbase, whichever we did in SQL Server. And it was a great learning.
The future enhancements. Our project has covered the backend version of the ASU event management system. So we can make this more user-friendly by having the front-end application connecting our database server. We can even add more tables to record the event happenings, performers list, etc. We can also get more insights on event success or failure and then make further changes. So finally, to summarize all of this, we created an ASU event database management system in both Microsoft SQL Server Management Studio and in Couchbase. After a brainstorming session, we finalized the questions that will answer in this project. We have given example queries which will cover join, store procedures, user functions, triggers, CTEs. We have also created cursors to send reminders. Using the different normalization forms, we performed 1NF, 2NF, and 3NF on our database tables. In order to implement NoSQL in Couchbase, we developed 3 buckets with the JSON key value format docs for the ASU event, persons, and event registration. As there is no foreign key references in Couchbase, we combined multiple tables that we had in SQL into 3 tables in Couchbase.
In conclusion, using this database management system, it will benefit both the users and also the ASU event organizers to decide on future events and assist them in making wise decisions based on past data.
So through this project, we were able to gain in-depth knowledge of the various querying methods like generating scripts, using user-defined functions, store procs, cursors, and triggers. Also, we got a chance to play around with data using different types of SQL commands.
And also we have implemented our project in NoSQL using Couchbase database by creating buckets. This data will be stored as documents in these buckets as key value format. So this project can be used by application programmers, database designers, and the administrators for different purpose of the ASU event management. And finally, this project has been a great learning for all of us.
So thank you. Hope you liked our video, and thanks for watching.